Good evening everyone. My name is Dheeraj Tawani and this is Umarpreet Singh, and today we are going to talk about a project called ArgumentGate. The main aim of the project is to be able to classify an argument with respect to a given problem statement or a topic, and we assume a good argument to be a one which influences a lot of people. So talking about our data source, our primary data source was the subreddit page called Change My View, and this page defines itself as a place where individuals or users can post their opinion and have a healthy conversation or discussion with other users about it. The motivation behind this particular subreddit page is because of the rich content with respect to the number of users, the number of posts and the number of comments, and also the fact that the owners of the page have created strong regulations that reduces the number of spam messages inside of your posts and comments. Now talking about the data itself, an individual who is interested in having a conversation about a topic or an opinion can post their opinion, and this serves as a statement to our model. The other users can comment on this particular post with their opinions, with their arguments, and these arguments are serving as the arguments of our model. Now talking about different values that we are considering, talking about the delta value is basically a value that is given to an argument whenever an individual feels that this particular argument changed my opinion. If they feel that an argument has a strong point, they can give a value of upward, and if they feel that this is not a strong argument or this is completely wrong, they can give a downward. Now talking about the data scraping part, we used the Pro library to scrape 9 years of data. We were able to scrape almost close to 110,000 posts and close to 1.4 million comments, which are basically arguments, and then we also scraped these metadata for all the posts and comments. Talking about the data cleaning process, we removed rows which had values less than 1 upvote. Then we removed rows which arguments were deleted or removed because of those regulations. Then we removed any external links, images provided in this posts and comments. And finally, we inputted all of that into the ArgumentGate to clean our text. After cleaning the data, we were left with 1.2 million data points, which were combined with their respective tokens to act as, and then finally this acted as our final input to the model.
Okay, so we tried multiple data labeling schemes, and this one worked best, and also it made sense. So all the comments which had delta greater than equal to 1, we labeled it as changed an opinion. And all the other comments which had upwards greater than equal to 30, we labeled it as an excellent argument, and between 15 to 10 we labeled it as adequate, and all which had upwards equal to 1 we labeled it as inadequate. We had lots of examples as inadequate, but we only selected 50,000 to keep the balance between data. And we also ignored some of the examples like between 30 to 15 because we don't want any overlap between data. So we are doing comparison of accuracy, precision, recall and F1 along with training and testing loss to test our model. So our baseline model is BERT base model, which has 110 million parameter, and we used weight decay and dropout to prevent overfitting. So essentially our training size is around 113k examples, which is like 15% of our total scraped data. So also we used GPT-2 large as our main model. It has 774 million parameters, which is almost 7 times our base model. We used larger batch size of 256 to prevent overfitting along with dropout and weight decay. And we ran it for 10 epochs, and after 9 it started overfitting. So as we can see the loss curves of both baseline and GPT-2 model, and even for 10 epochs the GPT-2 gave the better results, and BERT was not able to learn properly. So our main results, like we had around 28,000 examples in our test set. So BERT was able to give around 44% of accuracy, and our main GPT-2 model gave around 64% of accuracy, which is almost 20 50% more than our baseline model. And for our discussions, what we learned is that the amount of data processing and data labeling, it is very important for the project, because we used only 50% of our total data, but it gave us much better result than we used when we used our total data. And also we learned that these larger models can very quickly overfit, because they can learn very complex functions when given large amount of data. And so it is very important to use overfitting techniques to prevent overfitting. And for our future work, we would like to research more on data labeling to use our entire data set for this project. Thank you.